in GCSE or IGCSE, you are going to get two types of LCM and HCF questions. First of all, with numbers. Let's say you have some numbers like 3, 5, 7, 9. You have to find LCM and HCF from there. And in the second type, you can get this one. The numbers will be given as the product of the prime factors. Then you have to find LCM and HCF. And in this type of questions, we have three different types. First of all, let's say this one. We have two numbers, A and B, and they are given as their prime factors. One thing to be noted here is that we have same prime numbers in both of them. This is the type 1. Okay, so let's see how we can find LCM. If you want to find the LCM from here, we will go a prime number by prime number, and we will find the higher power. For example, in between 2 to the power 3 and 2 to the power 4, which one is the higher one? 2 to the power 4, right? And then 3 to the power 4 and 3 square, we have 3 to the power 4 as the higher power. And in 5, we have 5 to the power 7 as the higher power. So that is it. It's your LCM. Just find the higher power and your LCM is done. And HCF will be exactly opposite. For example, here we have 2 to the power 3, the smaller one. We're going to take the smaller one for the HCF. And between 3, we have 3 square. And in between 5 to the power 6 and 5 to the power 7, we have 5 to the power 6. And that's it. This is how, just taking the higher power, you can get the LCM, and taking the lower power, you can get the HCF. But what if there are different prime numbers in A and B? What can happen? Let's look at type 2. Now let's look at number A and B. See, again, we have numbers as the product of their prime factors, but in A, we have prime numbers as 2, 3, 5, 7, and 11. But in B, we only have 2, 3, and 5. So how do you solve it? Remember that when we have some extra prime numbers in one of them, and they're not in the other one, we still have them here, right? What we can do to make the math very simple, we can just put 7 to power 0. And we know that when something is power 0, that is basically 1. So adding 7 power 0 here, multiplying 7 power 0 here, it doesn't change anything. Just like that, we can also write 11 power 0, right? So now that you have the same prime numbers again, so just like that, you can get the missing prime numbers in one of them. And then it becomes simple. Again, just like that, we take the higher power for the LCM. Just take the higher power for the LCM. So 2 power 4, between 3 we have 3 power 5, between 5 we have 5 power 7, between 7 we have 7 power 6, and 11 square, right? So that's our LCM. When you go to HCF, we take the lower one, so 2 cube, and between 3 square and 2 to the power 5 we have 3 square, and we have 5 cube from the 5. And now between 7 to the power 6 and 7 power 0, 7 power 0 is the smaller one, and 11 power 0 is the smaller one here. Basically, both of them are 1, right? So we can just write our HCF as 2 cube, 3 square, and 5 cube. That's it. Again, LCM and HCF is done in the same way. We just had to either think, or we can also write that we have the other missing prime factors here as power 0. And you can solve it in the same way. Now let's look at the last type of the questions. Now, in the last type, we have the same things, but the questions have changed a little bit. Now that we are not finding LCM between A and B only, we are finding LCM between 5A and 13B. So first of all, let's find 5A. See, if you want to find 5A, you are supposed to multiply A by 5, right? Now the common mistake is that we are going to multiply all of them by 5. Do we actually need to do that? No. This is the common mistake here. We don't need to multiply every prime number by 5 because they are multiplication, not addition or subtraction, right? We only need to multiply 5 with this one, with the 5 to the power 7. So if I multiply A by 5, the 2 basically is not changing, 3 is not changing. Previously I had 5 power 7. I'm multiplying another 5 here, so it's just going to be 5 to the power 8. Nothing else is changing. See, so 2, 3 are not changing, and only 5 is changing. If I had multiplied A by 2, only 2 power 4 would become 2 power 5, and the others would remain same. That's the thing here. Now see, we have an extra prime number there, 13. which we don't have here. So we know that we can write 13 power 0, right? Okay, now let's find 13b. Again, we are multiplying b with 13. We don't need to multiply anything with 2, 3, and 5. They remain as they are. 2 cube, 3 to the power 5, and then 5 cube. Now we had 3 13s multiplied together, 13 cube. We are multiplying with another 13. So this is just going up by 1. So now we have 13 power 4. And then the LCM and HCM will be found in the same system. For LCM, what do we take? We take the higher one. So which one is the higher one between 2? 2 power 4. Higher one in 3 is 3 power 5. Higher one is 5 is 5 power 8. And higher one in 13, as we have seen, is 13 to the power 4 that we have got here, but multiplying by 13. Okay, so that's your LCM. Now HCF, we know that we need the lower one. So the lower one is 2 cube. And in 3, we have the lower one is 3 squared. In 5, the lower one is 5 cube. In 13 power 0, we can write it, but then we can choose to not write it. That's fine too, or just 1. Okay, so this is it. Even if you have something multiplied with your numbers, you can just multiply with that same prime number. You can get your answer just like that. It's as easy as it is.